Hi, my name is Charles. I'm a member of technical staff at OpenAI, and I will be talking about harnessing LLMs for scalable data minimization, where by data minimization, for the purposes of this talk, I mean the general notion that one should only collect and retain personally identifiable information, or PII, as necessary for a specified purpose, meaning also one should avoid processing irrelevant PII and take steps to expire PII when it is no longer needed. And by scaling data minimization, I mean the idea that the privacy-focused engineer will need to understand and influence potentially large numbers of code modules, data stores, and employees across the organization, especially as the organization grows. So it all starts with data stores, where we need to be able to inventory the types of PII that are present across various data stores. And once we have an understanding of the data, then we need to be able to control what happens with it, which occurs in code. So for example, we need to set retention deletion configurations, or we may seek to forbid certain data flows so as to prevent a phenomenon of data sprawl that would run counter to minimization. And this all hinges on people, where we will need to work with potentially many teams across the organization to understand the purposes of processing certain types of data and to facilitate decisions around data deletion. So in this talk, I will explore how LLMs could help us improve the accuracy and efficiency of these various data minimization processes. Obviously, we are always interested in seeing how our privacy work can benefit from various AI tools, so I'll share some experimentations and learnings that we found useful. Starting with data, where, as I mentioned, often the task at hand is that we need to classify PII across diverse data stores. And so how can an LLM help us with that? Well, we can prompt and later even fine-tune a foundation model to recognize PII categories in different forms and contexts. So for unstructured data, such a model might help identify PII spans in some free text, for example. But for the purpose of this presentation, here's an example of some structured data with phone numbers. And we could simply prompt our foundation model and ask it, please pick the correct label for this data object from the following 4 options, say name, phone number, email address, or other. And along with that, we can pass some information about the name of the table we're talking about, the name of the column we're interested in, and a few examples of the data in that column we're interested in. And from there, the model can pick the correct label. So one strength that we found with this approach is that it can recognize a wider variety of PII with higher accuracy than traditional rules or regex-based approaches, say if these phone numbers come in many different formats, potentially even very non-standard formats. Say in this toy example, the area code has been split off, but the context, say the column name, still makes it clear that we're dealing with phone numbers. If there's ambiguity, as I mentioned, the model can take context and potentially even domain knowledge into account to make the correct decision. And another strength of the approach is that since the foundation model already has an understanding of the world, it allows us to adjust the categorization scheme or the taxonomy flexibly. So say today we care about the 4 labels, name, phone number, email address, or other, but say tomorrow we're working on some other privacy use case and we care about a different set of labels, say the 2 labels contact details or not contact details. Obviously, in the phone number example, contact details would be the correct label here, but even if the data were completely different, say we had some email address data, then the same label, contact details, would apply. And so you might imagine how if we're working with traditional rules or regexes or even targeted specialized ML models that we train for each category that we want to be able to detect, then changing the taxonomy or the categorization scheme could come with a large amount of developer overhead that we won't have if we use a foundation model and we just need to tweak our prompt a bit. And so this flexible, automatable approach becomes especially useful if a large organization has many diverse data stores and a complex, potentially evolving PAI taxonomy, because then it can really shorten the turnaround time for a draft classification with good accuracy. Obviously, there are also limitations. For example, this approach is higher latency and much more resource intensive than a lightweight rule engine would be or smaller models would be. And also, if one doesn't have the LLM in-house, then sending the data examples to a third-party model provider could in itself conflict with the spirit of data minimization, although mitigations like zero data retention offerings exist. All right, so getting to the second part of the talk, we are switching gears from data understanding to code understanding, where often we may want to review and forbid certain data flows to minimize sprawl. So again, how could an LLM help us with this? Well, now we have these coding agents that can do long-running tasks and take sequences of actions or use tools. And this can be really helpful for mapping out the data flows in a code base, we find. So say we have some code for a toy application, and now we ask our agent, what external data does this app store and where? So from there, the agent might go, and first of all, it could determine whether this application even serves external traffic from the public internet or not. And if it does, it can analyze the different endpoints and figure out what kinds of PII they take from the user and potentially store somewhere. So in this example here, there's a save phone number method. Next, the agent could decide that now it needs to find the implementation of this save phone number method. So that's where it becomes really useful that it can search the code base and trace dependencies, and it might ultimately find the implementation in some other file, and now it can analyze it. For example, it may find that the phone number gets stored in some database, it gets written to a cache, and a success event is logged with some ID. So next, the agent can decide that now it needs to find the storage infra that backs these various data layers. And once it has found all the relevant references, it can put its findings into the output structure we requested and essentially give us back a table mapping our application to the various data stores that it uses, along with relevant data types and backing storage infra references. And so once again, I think that this approach is particularly useful in large, complex systems that are continually evolving, where we might have many different data stores and services and applications, and it's too much for a single privacy engineer to stay on top of all the time. And so improved tools for understanding code can really reduce the manual effort of reviewing new systems that have been built. I think many of us have had this experience that chatting with a chatbot can help us ramp up faster on some piece of code that we're working with. But we can also take this to the next level and spin up many agents in parallel that can regularly extract up-to-date insights from thousands or even millions of ever-changing modules for our review. And obviously, the agent cannot just help us understand the code, but it can also change the code. So this can help us accelerate removal of undesired data flows by drafting the required diffs. So for example, we decide that we want to exclude certain data types from certain kinds of logs. We can instruct an agent to find relevant logger calls that may not have been migrated yet and put up diffs to remove them. So how does this compare to traditional static analysis? Some of the advantages are that now we can trace flows across multiple layers of the stack without creating custom parsers for each, which would be a lot of work. So this reduces maintenance overhead, and also it allows us, once again, to iterate rapidly on the types of questions that we ask about the code base. And then also because the approach results in a semantic understanding of data and its flows, it can, and it can even take into account domain knowledge. This can really improve the precision for privacy use cases. Some of the limitations and learnings we've encountered are that context length caps the amount of code that can be considered in one analysis. So if we're working with large amounts of code, it becomes important to think about how we are going to divide the work into separate agent tasks. And of course, false positives and hallucinations can always occur. So I find that specifying detailed analysis recipes, much more detailed than the toy example, can help give good reproducible results. And also cross-referencing those results against production logs helps weed out code paths that are present but not actually exercised in production. All right, so getting to the third pillar, people, as I mentioned, often will need to facilitate organizational decisions around data deletion. And two questions that always come up are, is this data asset, say this table X, still needed, and who owns it? So how can we figure out the answers to these questions without knocking on too many doors and taking too much time out of too many people's day? Well, we could start by looking through the various internal documents that we have at the company. And we might find one that indicates that some team A has created some data pipeline P. And then we might find another document that indicates that this pipeline P is the one that used to produce table X, but now table X has been deprecated in favor of table Y. And then in a third document, it might be announced that person B has been hired to lead team A that maintains all this. So you can see how an LLM that can reason over this mass of internal documents could help provide the answers that person B is the owner for this table X, and probably table X is no longer needed because it has been deprecated. So this approach can help automatically close gaps that we might have in traditional ownership frameworks, say, if an employee departs. And also, it can synthesize various bits of usage information that are out there to facilitate and streamline the decision that person B ultimately makes, which is to approve the deletion. All right, so hopefully this has given a sense for why I think that LLMs do provide new architectural components that we can leverage for data minimization, namely a new kind of PII detector, a privacy coding agent, and a new kind of org context assistant. And so now we can put it all together, say we decide we want to be more proactive about data minimization, and we want to build an automated system that can nudge the organization towards improved retention practices. So we could build an automated pipeline and call it retention watchdog. And the first thing it could do is use our PII detector to figure out what kinds of PII we have in various data stores. And then it can check whether our retention configurations are set appropriately and correctly for the types of PII that we are handling. And if not, it can use the coding agent to draft the required code change, and it can use the org context assistant to figure out who needs to sign off on that. And then it can notify data system owners and ask them to please approve the diff or else take some other actions. And finally, it can produce a report for our various privacy stakeholders, informing them about what adjustments have or have not been made. And so automation like this can really optimize the signal that we get from the nuanced human judgments, while also reducing the effort and potential human errors that we might have if we didn't have this automation. So to sum up real quick, LLM-based tools can improve the accuracy of data minimization and give valuable focus time back to product developers. And in our various experimentations, we found that the tools were especially strong at detecting PII in context, and also at converting masses of code and documents into more structured insights that we can use for improved data governance. And yeah, it's been really great to be at this conference and listen to all the talks, and really looking forward to the upcoming ones as well, and to really learning with and from this community how we can enhance privacy further for AI and with AI. So thank you. Any questions?